Okay, so in 4b it says describe how the scatter plot from 3a represents the same information as the expression you wrote in 3b. So we're comparing 3a and 3b. Now let's go check those out. In 3a is our graph. So we're comparing the distance that you walk through the jungle changes how long it takes you to walk to the safe house. Now, the strategy for this is that we want to compare some of the values on the graph and put them into our equation to see if we get the same value. So we're going to put this value into our equation and see if we get this value back out. And that will prove that our equation models the information on the graph. So I rewrote the equation in here, and we're going to run the equation for 3.8. And you can pick any point that you want. You could pick a lot easier point than 3.8, but it's just the one I picked. So we got 3.8 divided by 1.8 plus 4 minus the square root of 3.8 squared minus 9 divided by 3. And we want to see if this value equals to 2.67, I believe. So if I start punching this out, we get 2.11 plus 4 minus, let's do the square root. Square root of 3.8 squared minus 9. So we get 4 minus 2.33 divided by 3, and then we get 4 minus 2.33 divided by 3. That equals 2.11 plus 0.56. Now let's add that to 2.11, and we get 2.67 if you round it up. Okay, so we put in 3.8 and we got out 2.67, which compares to our graph here. So our equation is a good model of what we have going on in our graph. So let's write that down. So see blah. If I take a value from the graph, let's see, I should say I erased everything. Here we go. Back on track. I get the same solution from my equation. 3.8 and 2.67. Okay, and I think that's a good enough explanation of how our equation matches our scatter plot. So if you have any questions, make sure to ask. Now let's go on to the final question, which is problem number 5.